Hey everyone, my name is Matt, and this is Donavan. Welcome back to our home edition renovation remodel thing, whatever we're calling this thing.
Demo day 2.
Sort of, though.
Sort of.
So yesterday we did most of the demo in the old entryway, and today we are maybe changing gears a little bit because our HVAC subs are here. So excited for a few reasons, mostly because we're going to get those ducts out of the hallway.
Yes.
That's the biggest reason, but we're also kind of moving forward in that realm too, so it's like we're knocking some things out. So we were planning on doing a lot more demo today, but with the HVAC guys here today, we're trying to work with them a little bit to get everything they need in place to figure out what they need.
Yeah, we've got a couple of spots where we've got a lot of stuff going in a really small area.
Let's cram it all in.
And so we're kind of massaging where locations of returns and supplies are a little bit now that we've got it wide open and we can see it, because a lot of times we couldn't see it before. So we're going to open up this opening, which will be the new access
to this room,
from the great room into the kitchen. And then on one side will be the breakfast nook, and then on the other side will be the main kitchen. So this will be the main path, and
in the main path is what?
A fresh air return.
A giant return.
That's got to go.
So part of what we're doing today is figuring out where the new return is going to go. We're gonna figure where all the supplies are going to go for everywhere else in here too. So it's going to be a little bit of HVAC and maybe some demo. Well, definitely some demo today and mostly HVAC. So you're going to cut the rough.
Just kind of get this roughed in so we can kind of see through and kind of just get better visibility.
And jump through the wall.
Jump through the wall and cut off the load bearing.
That's how you should do it. You just make your cuts and then jump through the wall.
There you go.
Here. Easy, look at that. That's a Nord Fab, huh? Look at that, in case you want to remove a duct to cut a hole in your wall.
Fabulous. We're in Matt's shop, and he's got a great job of doing all the drywall that we're going to destroy. This is got the supply and return for the great room, which is right above us. And in order to change the trunks that were in the staircase, we need to get access in here so that they can disconnect them and then reconnect them. So we got to open up this ceiling so they can get access, basically.
Should be fun. Here we go.
Yep. Almost.
Trying to make a bigger mess?
Grab the old man, he's falling over.
Pretty hollow.
There you go.
That's a lot of space, like dead space.
Yep.
I didn't realize it was so empty in there.
Yep.
Why did it make it so big then?
I don't know.
House is too heavy. Gotta lighten the load. Haven't you ever seen Up? Come on. Get with it. We got balloons to send up.
I couldn't even get, like, lift myself. Let's go put that right into the, yep.
So we're gonna start cleaning up some of the wires and stuff.
Watch your head.
All right, this is the coax for TV, and there's an Ethernet line. So they got a couple of lines that they pulled at some point that terminate here that were never used. So we're gonna pull them back and probably reroute them, but at least get them out of the way for now. Oh, they glued them in. That's nice. They're literally glued in, like hot glued or silicone or something. Very nice. Well, I gotta pull them all. All right, so we're here with Jordan from Perfection Heating and Air Conditioning. Jordan and his crew is going to be helping us out with our HVAC situation here. So to give everyone a little bit of a background, what we have going on here in the house, we have two HVAC systems. Actually, we have one that handles the original 1960s house, and we have a second system which handles this addition, which was added about 15 years ago, which you're now adding on to. So we're going to be primarily tying into the additions HVAC system for this sort of phase of things. So Jordan is going to tell us a little bit about HVAC and how that all kind of works and things to think about. So just sort of general, very large umbrella questions like, how do you go about sizing a system for heating and cooling for the size of the house, or just by square footage, or are there other variables that you might want to take into consideration when you figure out, like, this is the size of furnace that I need, this is how much of how much tonnage for my AC I need, or whatever?
Yeah, that's a great question. So on figuring out load calculations for any home,
there's the word for it.
Right,
load calculations.
It matters on your market, region. What region do you live in, right? What's your temperature? In Minnesota we have extreme temperatures, right? 40, 50 degree swings in 24 hours sometimes, right? So our market's going to be different than California or Arkansas, right?
Right.
So with that, now there's a book. It's called Manual J. It was engineers years ago came out how to figure out how to measure R value in a multiplier for what the loss is, like what the loss or the gain. We put basically your square footage in, exterior walls, what's below grade, what's above grade, and your building materials being used. So you could have two houses look very identical in the same market, in the same region, and come up with a different heat loss based on materials used. These days, spray foam is being used, a lot. So typically you're gonna get a little higher R value, a little better seal, so your infiltration rate drops, versus like a standard bad insulation. So there's a tremendous amount of variables on load calculations.
So if you're doing a really good install, you actually be thinking about those things. Is that like a software you have, or just you can like put in a bunch of different variables? Is that how that works?
Yep. So we basically would pick one wall, like your new wall here. We'd pick it what size, what direction it's facing, north, south, east, and west.
right.
That matters. And we basically put the square footage in it. We'll pick the building type based on blueprints or site visit, discovery, and then as you go through the whole project, it'll basically come out with a number for you. You can do it by hand too, but this day and age with computers, why would you, right?
So then with that, how do you go about translating that into like, where do I put all my ducting, and how big of a duct do I need for whatever space? How does that kind of play in?
That's a great question. So if you're doing a full load calculation, it's going to tell you based on, you can do two different ways. You can do an envelope, so basically outside walls, that's my loss. Or you can actually approach it in a much more refined method, is a room by room method. Doing it by room method, it's actually going to give you the CFM per room needed to achieve the loss or the gain of the room.
Right, so like for this room here, this is like 600 square feet. That's going to need a different amount of heating and cooling than somewhere else that's maybe 200.
Correct. Or you could have two rooms that are 600 square feet. One could be interior, or one could have one outside wall versus one that has 4 outside walls. One could be facing south and west with 80% glazing glass on that wall, that your solar gain would be massive. So like, you can't, there's no rule of thumb out there. I can't say, for every square footage, this many BTUs is needed. There's just way too many variables.
So like the sunroom now, we've got a lot of glass going into the sunroom. So we'll probably have a higher AC requirement than like a standard stud wall. And if it was south facing, it'd be different than we've got east facing. So it'd be south with glass is going to require more AC.
Correct.
Probably heating at the same time.
Your eaves coming out on your fascia, your soffit, like the further you go with that, the changes the angle of the sun, that will actually help with the load. Windows are typically going to be your highest transfer of heat, or so we typically will put supply ducts on the outside wall to create an infiltration blanket. Basically gets the airflow flowing to help stop the migration of the cold or the outside unconditioned air into the conditioned area.
Oh, it's like a invisible wall kind of thing.
Absolutely, yeah. Yeah.
Let's talk a little bit about this specific install here for the house. So we have an existing system you're tying into. That cause any challenges at all as far as like, can we add on what we're adding on to that system? Or is there anything weird that kind of happened when you're thinking about that?
The remodel is very close to the mechanical room, so that's good. The accessibility, but like if you have a furnace on the south side of a house and your addition's on the north side, and you have to outweigh what you're going to be changing to keep that system. You could put an addition on a house and it could be 300-400 square feet and make very little impact on the load. So the furnace and the equipment that you have right now might not be affected at all. So for instance, on this house, our furnace is basically on this end of the remodel, and we already had a trunk line, which is our main ductwork that basically...
The big one, that was the one that was underneath our staircase, which very excited for that to go away and get out of the way.
So the main trunk line basically is delivering the air to the branch ones. It's actually going to deliver to each individual room, right? That is sized to handle the capacity of the load, right? So how many BTUs we need, we have a calculation for BTUs compared to CFM. In this case, we had to enlarge it a little bit bigger because we're probably adding 4 additional supplies to the system.
On this, we got rid of some supplies too.
Yes, yeah, on this end, yep. And so yeah, we got rid of a trunk line on that side of the house, on the north side of the house.
Yep.
And we increased it on the south side. When we increase the amount of run, the supply, it's going to maintain our velocity and basically our BTUs. Like, because for every CFM of conditioned heat, it's producing a BTU, right?
No, I don't know.
Yeah,
Is that how it works?
that's how it
Right,
works.
right. Yeah, I don't know. Sure.
Sure,
Like,
we'll go with that.
You can't heat without BTUs, right? So why it's so important to make sure that your main trunk line is sized appropriate for your individual branch ones is air is a lot like water. It's very lazy. It's going to take the least path of resistance, right? So if I didn't upsize that trunk line, the heat and the air is going to go to the closest registers. It's going to find its way out. And it would have affected this existing structure, the existing room over here, because the time the ductwork gets out here is, I'm not going to have that velocity, I'm not going to have the volume. So you can't just, I'm going to put addition on here, I'm not going to touch the trunk line, I'm just going to add a couple extra runs on there. That will affect you.
So 2 things I learned today. Air is lazy. Oh, 3 things. CFM equals BTU.
Yeah.
And then HVAC is basically like trees because there's a lot of references to trunks and branches.
Right?
So it fits in pretty nicely to everything else we do
There we
around
go.
here with tree stuff.
Yeah, exactly.
So real quick, lastly, you want to run us through the plan of where everything's going to go and get reconfigured?
Sure, yeah. You can see the blue area is the new addition, so that's the area we're going to try to condition, and the white area is the existing home. The mechanical room here currently, the furnace is actually right about here, and our ductwork is running this way. So that is our main trunk line. That's what we talked about earlier about how we had to increase because we added additional supplies, branch runs to the addition area. So the office space is also being heated through in-floor heat, which is heated through the slab. So we are not going to try to cover the heating load for the office space. So all we're going to try to do is cover the cooling load, which is going to be minimal because I would say 2/3 of this area is below grade. It's insulated really well. So what we're going to try to do is, like we spoke before, about creating an infiltration blanket across that window. So we're going to put a ceiling supply blowing down. The deflection is going to be a double deflection to the right and left, and the throw of the register is designed to have a 15-foot throw. Why that's important is when we have a return coming back through the wall somewhere in this area here, we're going to be able to splash that floor and create a good airflow cross stream across that room that should create comfort.
So in theory, the air should be like, I'm coming from here, and I'm going to go to here.
Yeah.
Just recirculating.
You know, we size basically for about 1,200 feet per minute in the main trunk line, and we try to be between 600, 900 feet per minute on the branch runs. And if we vary on that, if we're lacking, we're not going to get a full throw out of that register, and that's going to create comfort issues. In the dead of summer, you might need it, but with the insulated foundation, which is unbelievable, and the return, it's going to maintain a very, very comfortable temperature in there. We got a lot of glass here.
Yeah.
So what we're trying to do here is we're gonna throw some supplies in here. We're gonna try to splash these windows.
I like the words you use for this, splash them.
Yeah.
Where would you splash anything around here?
I don't know, maybe with a bucket of water and some wood on the back or something.
Oh, that'd be cool. Somebody should do that.
Let's make some cool videos.
So most registers are going to deflect left and right. So we don't want, we wouldn't want to put something right in a corner because we're only going to get really deflection on one side of it, and it's going to probably stagnate in one area. Keep that in mind when you're laying out a house. Like, make sure that the register basically has room to throw, right? We're going to be throwing 15 feet. So at an angle, 15 feet up like that, right? I mean, we all been in the house. We go to a house with south-facing wall, west-facing wall. You walk up to a window and you can feel the heat, right? Mm-hmm. Everyone's experienced that. So like, you're trying to lessen that when you have, when you're hitting your ductwork on the outside wall. Create that blanket, make that heat work a little harder to come in. And then, return air, I believe we're going to be putting it on this wall here.
Yep.
So I get a lot of questions on return air placement. One thing you can do that, depending on like 2-story houses or high elevations, we typically, if the supply is on the floor, which is very common these days with our construction, we'd like to get to the return air as high as we can, right? Pull that heat from the air or from the top of the ceiling. That helps With the new equipment these days, variable speed or ECM blower motors, the fan should be running all the time. It's very inexpensive to run. So it really helps promote removing the heat from the top air. Even in heating season, if you're trying not to really remove the heat, you have heat stagnated on the ceilings.
You're just trying to keep it circulating and keep it
Correct.
more even across from top to bottom. If
Yep.
It's moving.
Yep. I challenge anyone to take a laser, one of those laser pointers, and if they have tall ceilings, is measure your temperature at your floor and measure your temperature, and you can
Huge
easily have an 8 to 10 degree difference, like easy.
Yep.
Especially like a ceiling like this, for sure. But also think like the return things. Like, why do we have returns? And some people think there's a lot of discussions on how it all works. I don't know if anything's right or wrong, but furnaces are non-pressurized systems. They pull what they push what they pull. A great way to explain it is if you had a small room, you had one supply in it, no return, and you had a threshold on the door, right? So it couldn't breathe, there's no leakage, and the door is shut, and your system's running. Eventually, you're gonna achieve the same pressure in the room as you have in the ductwork. And if we have no differential on the pressure, we can't move air.
Right.
So it stalls it.
It stalls, yeah. I mean, we're measuring ductwork at like 0.1 inches of water column. That's really small measurement. Doesn't take a lot to get that. So like, if you have equal pressures, you can't move air. If you can't get a return in a room, undercutting a door, doing a transfer grill, things like that to help promote airflow. In this situation, is we can't get here with the framing. It's cantilevered out, correct?
Yeah. And it's very difficult to get
It's very difficult to get out there. So what we're going to do is we can heat with not hitting the outside walls. We just have to make sure we have enough volume of air to deliver the BTUs we need. So we're going to go put a toe kick in the island area. So what a toe kick is it fits in the toe kick space, out of sight, out of mind. A lot of people like them because you don't see them. So basically, we're going to be coming up right here, and we're blowing out under the cabinet. The old system, we had a trunk line running through here. The existing system ran through here, and then it picked up a big return. But with the new framing configurations, we really can't make it work. So what we're doing is we basically reconfigured the trunk line downstairs for to accommodate the new office and addition, and we are splitting two returns here and here.
The old return was basically you'd come through this archway and been over the top of it. So we wanted to get it kind of out of the way so it's out of the walking path. And
I know one thing that we kind of talked about in passing as we're kind of talking about the returns and everything is getting the supplies and the returns like the same size. Is that the gist of it? Do you want like the same amount of return as supplies, like square inches?
Yeah, so
or sectional area?
That's a great question. So like we spoke about that earlier, like the system is not pressurized. So you theoretically should have the same resistance, which we measure that in static pressure on the duct system. So we typically will size our supply trunk line for 0.1 and our return trunk line for 0.1. And then based on that, we have a tool called a duculator. It's basically a calculator for ductwork. So we can basically say, okay, we're at 0.1, we need a size ductwork, right? That's going to give us our CFM. So then we work it backwards. Okay, I have the ability, let's say I need 1,000 CFM, and I can get 10 returns. Well, for easy math, that's we need 10 or 100 CFM per return, right? Mm-hmm. So we want to make sure that we're making sure that we have the same amount of CFM going back to the furnace. Not so much the same amount of one return and one supply. Like it's not a 1-to-1 ratio.
Yep.
It's a CFM ratio. It's a balance ratio. So 1,000 CFM in supply and 1,000 CFM on return.
And the way I've seen it typically is you have less returns and more supplies.
Yes. Typically, and the reason why that is our returns are bigger. Yep. We do that for a couple different reasons. A bigger duct is going to have less velocity. Mm-hmm. Velocity is what creates air noise, right? So we want our returns to be a little quieter. We're not trying to throw 15 feet like a register is. We're just trying to pull back. Yep. So we don't need to have the velocity. So we increase the return. So increasing the return size too, it's gonna pull more CFM.
We're both really excited for everybody to get in here and rearrange things, especially get those ducts out of the thing.
It was so nice that those fighting around those two ducts,
under the
trying
stairs
to pour
there.
the concrete, trying to do everything was painful.
Where the stairs were.
Yeah,
where the stairs were. That was awful. So and you guys, the guys who've been out on our site have been great. So
It's great to hear.
It's good to have a good company that
Yeah.
they're checking in with us all the time. Like, can we do this? Do we do that? And it's at least something on my part of I appreciate, because they're checking in and not just doing something and then somebody's getting yelled at later.
Well, it's all about expectations, right? So like your expectations might be different than mine. So if I just go in and do it the way I think I want to do it, there was no communication. Most likely, someone's going to be upset.
Yep.
You know,
Yeah.
and the communication always promotes, like, if I have to redo something because your expectations was different than mine, right? I'm not going to be happy, right?
Right.
So, and you're not going to be happy because now you think we're incompetent because we didn't communicate, right? So communicating, I mean, there's a lot of things that just go into where we put supplies. I mean, if it was up to mechanical contractors and, and plumbing and electric, I mean, they're going to do it, the house will look completely different, right?
Yeah.
So we also have to keep in mind that people are living in their home, they want to look a certain way.
Yeah.
So there's a lot of communication, a lot of planning that goes into these projects.
Well, and on like this one, we've got HVAC, we've got plumbing, we've got the boiler, and everybody's competing for the same space.
Absolutely.
And I try to get like, okay, guys, let's figure this out and try to work together. Because at the end of the day, everybody's gonna be a lot happier. Mm-hmm. Because if you just go and grab your stuff and kind of screw the guy down the road,
Yeah.
it doesn't make for a good end product. But if everybody's having that communication throughout the trades, you got a better product and a happier client at the end of the day.
Absolutely. Yeah.
Cool. It's getting kind of late in the day, so I think we're gonna call it here. But
Yep.
generally, I think good-ish progress. Most excitingly, HVAC is starting to.
Yep, HVAC, we've got a plan because there was some questions about layout, so that's been, I think, Jordan went through everything and his crew, and we've got everything that laid out that everybody's gonna be happy. It's gonna be functioning properly.
Yeah.
And we don't end up with some wacky stuff to have to do. So I think
We kind of have our hallway now.
in the hallway's back, there's no ducts in the hallway, but there's no ducts on the
It's out of the
furnace at
way.
all.
Thank,
So tomorrow
thank
they'll
goodness
finish
it's
that.
out of the way.
Yep.
We have that set up, and then tomorrow we're starting on and getting rid of this wall.
Yep.
We'll see how far we get.
We got a little bit of a complication.
So we have all the foam up in here. They sprayed this rim, which
It's
maybe.
good that they sprayed the rim. I had forgotten
bad
the
for us.
time frame when they did this. So all that foam has to come off the existing rim joist,
So we can-
clean,
Yeah.
so that we can apply our new lamb beams to that. And there's no room to work up in there.
So
And we have to leave the wall in place until we do that.
yeah.
So it's going to be.
My little hands are gonna come in handy finally.
Yeah,
I feel like-
I think I got a different idea that we'll try to see if we can make that work.
Even better. So next time, tomorrow, for us, we'll be up there. Hopefully we'll get at least one of the beams up there.
Okay.
I don't know if we can do a whole video on scraping foam, so we'll see.
Well, it's going to be tedious, and it's just because we're going to have to go up in stages, and we're going to trim. We can't get the right LVLs, so
They're giving away too many of the details already.
okay. Never mind.
There's
Tomorrow you have to
There's
tune
going to
in.
be even more complications
Yes.
with this install, so get ready for that.
Yeah.
So that's going to do it for this one. Thank you as always for watching. I greatly appreciate it. If you have any questions or comments about this home destruction thing, adventure thing, or anything, please feel free to leave us a comment. As always, we'd be happy to answer any questions you might have. And until next time, happy woodworking.